Ladies and gentlemen, today we're going to be talking about linear recursion. Linear, constantly adding a value or subtracting a value to some sort of base, some sort of initial value. Recursion, something that recurs, a pattern. So we're talking about a linear pattern here. We're going to be dealing with this type of scenario. Suppose you start a new job earning $50 a day. You must sell subscriptions, and for each subscription you sell, you get $3.75 for that day. You need to be able to write a recursive rule and an explicit function rule to model your daily income. So I have the problem here for you to reference. The recursive rule is written as follows: m sub n plus 1 equals m sub n plus d. The explicit function rule, m sub n equals m sub 0 plus n times d. Now this may be a bunch of new fancy shorthand things that you're not familiar with, so let's go ahead and do some defining of these things. N is going to be the number of subscriptions that you sell. M sub n is going to be your daily income. And guys, that's going to be a total. And then D is what's called the common difference. Now difference means subtraction, but subtraction is just adding negative numbers. Okay, so that's what makes it linear, is that we have a common difference. Now n is going to change based on your scenario, based on which day it is. M sub n is going to change based on how many subscriptions you sell. M sub n is going to either be higher or lower based on how good a day you had selling subscriptions. And D is always going to be constant. Common difference. What are we adding constantly, or what are we subtracting constantly? In this case, we are constantly adding $3.75 for every subscription we sell. So D in this case is 3.75. So we need to be able to write a rule. Okay? So if we take a look here at m sub n plus 1. M sub n plus 1, guys, this means the next term. The next term. So the next term requires the current term plus the common difference. The next term, in order to get it, you must have whatever you're starting out right now plus your common difference. So our recursive rule for this scenario is going to be m sub n plus 1 equals m sub n plus our common difference of 3.75. This is the recursive rule. Notice the only thing that changes here is D. The other two are general, because you could be talking about the 81st term. You need the 80th. We don't know which term we're trying to find, but we do know in order to get to the next term, we got to add 375 to the one we're at right now. The explicit function rule, this thing helps us with, if we know the very first term and the common difference, then we can find any term we want to in our sequence. So, this here is the term we're trying to find. This one right here is the initial term. And then, of course, D again is the common difference. So if we take m sub n, we'll leave that the same, equals m sub 0. Where do we start? Well, it says here that we start at $50. So m sub 0 is equal to $50. So this is 50 plus n times 3.75. And that is our recursive, not recursive, explicit function rule for this linear recursion scenario.